Hey folks, so lesson 9, we're going to deal with higher derivatives. Now, this kind of also marks the halfway point of our long derivative unit. What happens after this, and that's why you'll notice in your course book, there's a review, and we're going to do a unit assignment kind of in the middle of this. We've split derivatives kind of into two halves. The first half is just dealing with how different ways to take the derivative. Okay, the second half, which we'll start in with lesson 10 for, is applications of derivatives. Okay, so with this guy, this kind of is a nice segue into applications because we're going to need to deal with higher derivatives in applications. Now, what do I mean by higher derivatives? It just means essentially taking the derivative of the derivative. Okay, so if I give you a function and I ask you to take the derivative, if I then looked at that derivative question in theory, or function, I guess I should say, if I looked at that derivative function in theory, I could take the derivative of that, right? Because it's still just an equation. And so the derivative of the derivative is called the second derivative. Okay, and where we would say like y prime to represent the derivative, y prime prime would be the second derivative. And in theory, we could just keep going, right? We could take the third derivative would just be the derivative of the second derivative, and so on. So in that sense, really, this lesson is fairly easy. There's nothing really new, as long as you pay attention to which derivative you're on, and make sure you're communicating that with the right, like with the appropriate number of primes there, okay? Okay, so determine the first and second derivatives of the given function. We're just going to go through a couple of examples together. And just a reminder what I just said, the second derivative is the derivative of the first derivative, okay? Okay, so in all of these, I've color-coded them. The red is going to be the original question. Then the blue will be the first derivative, and the purple will be the second derivative, okay? So first equation, f of x, equals x to the 5 minus 4x squared plus 1. If I want to take the derivative of that, I'm going to go, this 5 comes to the front, right? This is a sum or difference of terms, and so I just take the derivative of each term. So 5x to the 4 minus 8x. Okay, done. There's the first derivative. Second derivative will be the derivative of this guy. So now I'm going to go, the 4 is going to come to the front, so that'll be 20x cubed minus 8. Done. First derivative, second derivative, that question's done. Obviously, it's going to get slightly more complicated, but that's all we're really doing, okay? So this is really just a review of practicing derivatives. Okay, so f of t is 2t minus 1 over t, t plus 1 all squared. So I'll probably think about this as t plus, sorry, I said all squared. I didn't mean to do that. 1 over t plus 1, just 1 over t plus 1. I was thinking ahead, though, that I should have an exponent there, although it's not a squared exponent. I have no idea where the squared came from. I'm going to write that as t plus 1 to the negative 1, okay? T plus 1 to the negative 1. So if I go to take the first derivative, I have 2 for this guy. And then if this was t plus 1 to the negative 1 would come to the front, and that's why I'm now having a positive, and it would be t plus 1 to the negative 2, okay? Now, you would then take the derivative of the inside function, but the derivative of the inside function is just 1. T here is acting as x. It's acting as our input, so the derivative of that is 1. Where we would have to, like, I don't want you to get confused with implicit differentiation that we did in the last lesson. The issue there was we had to take the derivative of the output, not the derivative of the input, okay? Okay, so now to leave this as first derivative, you would want to write the t plus 1 to the negative 2 as 1 over t plus 1 squared, okay? Just because you can't answer with a negative exponent, okay? But now, to go ahead and look at the third derivative, really, to take a look at the third derivative, I kind of want to leave it in that form because I can do the power rule with that, right? I can see that a little easier. So negative 2 will come to the front, t plus 1 will then drop to negative 3. And this guy, oh, I took my ink off, sorry. This guy here will become 0. Okay, so the third derivative, negative 2 came to the front, t plus 1 dropped to the negative 3. So then as I clean that guy up, it'd be negative 2 all over t plus 1 to the 3. Okay? Great fun. Okay, next up. 4 over the root of t. Again, we are, just as a aside, we are kind of segueing into applications here. That's why I'm using t, okay? T is going to be my input of time when we talk about position functions and velocity and acceleration, but we'll deal with that in the next lesson. So the first thing I want to think about is that's like saying 4 t to the negative 1/2, right? Okay, and if that's 4 t to the negative 1/2, the negative 1 will come to the front. So 4 times negative 1/2, sorry, the negative 1/2 will come to the front. So 4 times negative 1/2 will be negative 2. And then negative 1/2 would drop a degree. So that would go to negative 3 over 2. Okay. So then to clean that up, that will become the t to the negative 3 over 2 will come back down to the bottom. So it'll be positive 3 over 2. So it ends up being the root of t all cubed. Okay. Again, though, when I go to take the second derivative, I want to think about it in this form so that I can use the power rule again. So the negative 3 over 2 would come to the front. So that end up being positive 3. T to the, well, negative 3 over 2 drops a degree. So I'm dropping essentially negative 2 over 2, right? So that'll become negative 5 over 2. Okay. And so my final answer for the second derivative, again, notice the second derivative, I have 2 tick marks, 2 primes there. And so that will end up being 3 over root t to the 5. Okay. Awesome. Okay. Y equals 2x plus 1 all to the 8. Okay, so this is the chain rule. Power law kicks in first. 8 comes to the front. 2x plus 1 drops the degree, so it'll be 2x plus 1 to the 7. And then I have to take the derivative of the inside function, which would be 2. Okay, so then cleaned up, that would be 16, 2x plus 1 all to the 7. For the second derivative, the 7 comes to the front, and then it'll be 2x plus 1 dropped a degree, so that'll be 6. And then again times 2, the derivative of the inside function. Okay, and so then I just clean that up. 112 times 2 is 224. Okay. Awesome, awesome. Okay, now this overall would be, so it's y equals the root of x squared plus 1, but we're going to look at that as x squared plus 1 to the 1/2. The 1/2 will come to the front, and then it will drop down to x squared plus 1 to the negative 1/2. Okay. That's high. I'm just going to hide myself for a second to make sure you can see that. Okay, so 1/2 x squared plus 1 to the negative 1/2. And then I had to take the derivative of the inside function as well. So the derivative of the x squared is that 2x right there. Okay. All right, so now I'm going to clean that up. I'm going to multiply the 1/2. Oh, sorry, I'm just trying to get my ink on while I'm hidden here. I'm going to multiply the 1/2 by the 2x, so I'll just have an x in the front. Okay, and that would leave me with x. And then I took my x squared plus 1 to the negative 1/2, drop that down. So it's x squared plus 1 to the positive 1/2 on the bottom. So then I wrote it as root of x squared plus 1. Okay. Now, for the second derivative, okay, again, right now I'm kind of at the spot where you would, now, actually there's 2 things I could do here. I could take a look at this and I could say, I'm going to use the quotient rule, okay? Or I could switch that root of x squared plus 1 back to being an x squared plus 1 to the negative 1/2 and use the product rule. Okay, it really doesn't matter which one you do. I know I've spoken to you in class about making sure that in a question, you do it the way, like you don't alter the equation, right? This is now beyond that. So this one, you would have a choice as to how you handle it, okay? So what I did was I did it with the product rule, okay? So my f was x, and my g was x squared plus 1 to the negative 1/2. Okay, so I'm looking at the derivative of f, that's where the 1 comes from, times g. Okay, there's my x squared plus 1 to the negative 1/2, plus f times the derivative of g. Now this all right here is the derivative of g, right? The negative 1/2 comes to the front. My x squared plus 1 drops a degree, so that's why you see it to the negative 3/2, and then I have to take the derivative of the inside function, which is that 2x. Okay, so now I just need to work on cleaning this up a bit. 2x times the negative 1/2 and times the x, that's going to give me negative x squared. Okay, so if I clean that up, just erasing my ink there, I get that negative x squared there. Okay, now I'm just going to write that on the next slide so that we can just keep doing some work with it. Now I want to do some factoring, okay? So what I'm gonna do is I'm gonna factor out the negative 3/2, okay? Some of you may want to have approached this as, let's just take those negatives and put them on the bottom and try and get a common denominator. That would work as well. I think it's a little easier to factor out the biggest negative first, because look, it leaves you actually with some nice, easily simplifiable items there, okay? So when I factor out x squared plus 1 to the negative 3/2 from this first guy, that leaves me with x squared plus 1 to the 1, right? I'm dividing, so an exponent of negative 1/2 divided by the exponent of negative 3/2, I end up subtracting those exponents, right? So negative 1/2 subtract negative 3/2 would give me 2/2, which is just 1. And then if I take out the negative 3/2 exponent from this guy, I'm just left with that negative x squared. Okay, so now when I go to simplify this, I've got x squared plus 1 to the 1 is just x squared plus 1. So I can go x squared minus x squared is nothing. So that's just going to leave me with 1 over the x squared plus 1 to the 3/2. Okay, which we could then write as the root of x squared plus 1 to the 3. Okay? Okay, this guy, y equals t over t minus 1. So again, we could use the quotient rule right now, or we could call t minus 1 t minus 1 to the negative 1 and use the product rule. Okay, I chose to write it as t times t minus 1 to the negative 1, and I'm going to use the product rule. Okay. Again, on a test, you wouldn't do that on a question that just said determine the derivative. If I gave it to you as a quotient, I would want you to use the quotient rule. Here, we've kind of gone beyond that because we're looking at higher derivatives. So here, you would have the option of approaching it however you wanted to. So we're looking at the derivative of f, which would be 1 times g plus f t times the derivative of g, which would be negative 1 t minus 1 to the negative 2 times the derivative of the inside function, which would be 1. Okay, so I didn't write the 1 there because it's just 1, but okay, I'm just in case you can't see that because my big old head might be in the way, I'm going to hide myself for 1 sec so that you can see what I just said. Okay, so now I'm going to clean this up. I don't need that 1 there. This can become negative t. Okay, and then I put it as fractions as well. So I've got 1 over t minus 1 plus negative t over t minus 1 squared. Now I need a common denominator. So what I'm going to do is I'm going to take this first guy, multiply him by t minus 1 over t minus 1. That gets me my common denominator of t minus 1 squared. On the top, I end up with t minus t, I end up with t minus 1 minus t. So that's actually just going to be a negative 1. Okay? All right, so there's the first derivative. Okay, so now to get the second derivative, I'm just going to look at this guy as -1 t minus 1 to the -2. Okay, so the -2 will come to the front. So that's going to end up being -1 times -2, which is +2. T minus 1 then drops down to -3. So I'll bring that underneath and it'll become t minus 1 to the +3 with a 2 on top. So the second derivative is 2 over t minus 1 to the 3. Okay? All right. Oh, let me get the ink off for you. All right, so here is your homework for that. Now, these are more pages because in your book, there's this review section as well, okay? And then we will see each other for kind of the second half of this unit. The next lesson will start in on applications of derivatives, okay? If you have any questions, make sure you're touching base with me and have fun. Okay, we'll talk to you soon, guys. Bye-bye.